This is Microstrip's bubble strip sampler for sampling dissolved hydrogen in groundwater. When you receive the sampler in your offices, this is what it will look like. It's a soil jar with a 3-hole rubber stopper. One port in the stopper is for water entering the sampler. It has a flexible tube, short flexible tube. The exit port is a long 1/4-inch polyethylene tubing. And the third port is a septum port, which a small septum is placed so that we can gain access to the vial. Now this is similar to the way that it will look at the well site. When you get there, the first thing you want to do after you've set up is to fill the sampler with water. This bottle I'm using is both the well and the waste can for purposes of this demonstration. This pump is certainly not the pump that you would use. You'd want to use a peristaltic pump if water depths are less than 25 feet, or a bladder pump if the water is deeper. Also an important part is this stand. It's important to be able to stabilize the sampler so you can take your hands away from it. So to turn on the pump, we'll fill up the sampler with water. We can take it away from the stand, tilt it, let the water escape through the exit tube, and once we've removed all the bubbles, we'll turn it over then with the septum down and prepare to inject a bubble of air using the disposable syringe that's been supplied. The bubble size that we recommend is 20 cc's, and so we want to take a 20 cc bubble into the septum. It just needs to be air that you'd be happy to breathe, not down the wind of a car exhaust or some other contaminant vapor that might be at the site. Then we will again take the sampler from the stand, insert the needle through the septum, and compress the 20 cc bubble into the bubble strip sample. Remove the septum from the, remove the syringe from the septum and place the sampler back in the stand. Now, this sampler has been evaluated and a published paper is in the literature in a refereed journal. It can be made available to you. It was determined that it takes 15 to 20 minutes to equilibrate the bubble with the groundwater using a bubble size of 20 cc's and a groundwater flow rate of 250 to 300 cc's per minute. Now when that time is elapsed, there's no lights that come on, no bells that ring. It's a very low-tech sampler, and you simply have to time it, and when that time is elapsed, we know that the bubble is equilibrated and we can turn off the pump. Now we have a 20 cc equilibrated bubble, and we simply need to retrieve it from the bubble strip sampler and place it into a sample vial. Do this using a disposable syringe, again, that's been furnished. Go in through the septum port, and remove a 15 cc sample. Now what you'll notice is that the volume in the sampler that was occupied by the bubble is now filled with water. That's water that's come back in through this exit tube. It's water that just passed through the sampler, and it's water that's at the Henry's Law equilibration concentration. And so its reintroduction into the sample vial will not alter the bubble strip or the bubble sample and the concentration in the bubble. Once that's done, then we can remove the syringe from the sampler after we've closed the stopcock, because certainly this sample is not at equilibrium, not at atmospheric pressure. maybe slightly less, and unless we close the stopcock before we remove it, it will go to atmospheric pressure by dilution. We close the stopcock, remove the needle from the septum, and now it remains to compress this sample into the vial. Insert the needle through the vial, septum in the vial, and compress the sample into the vial. Now, this vial was at atmospheric pressure with nitrogen, and so the introduction of the sample into the vial involves a dilution. We assume that you have injected 15 cc's, and we'll make the calculation accordingly. If you inject less than 15 cc's, you need to tell us on the chain of custody so that we can correct for that in the calculation. This is a sample that has been tested to be stable in this vial for up to 60 days. We don't intend to take that long with your sample, but it is a stable sample for a very long period of time. Thank you very much.